Hi, and welcome to the ONF Spotlight on 5G Connected Edge Cloud for Industry 4.0 Transformation. I'm Timon Sloan with the Open Networking Foundation, VP of Marketing and Ecosystem. And today it's my pleasure to welcome Renu Navale, VP and GM for Edge Computing and Ecosystem Enabling at Intel. Intel's been working with the ONF for many years and was an early supporter of ONF's work in the mobile space, including M-Cord and with Mobile Core. Now, with ONF's new Ether platform for private 5G connected edge, we're starting to intersect with the edge work that Intel is pursuing. For this reason, it's my pleasure to welcome Renu to the program today. Intel has a number of edge initiatives that align very nicely with ONF's latest work, so I'm excited Intel can share their latest updates in this space. With that, Renu, please take it away.
Thank you so much, Timon. Hi, everybody. It's definitely my privilege as well as a pleasure to be speaking at the ONF conference. As Timon said, I lead edge computing and ecosystem enabling, and I'm excited to talk to you about the work that Intel is doing with the open source communities like ONF, as well as the work around our technology innovations for 5G as well as edge cloud, and how this can be applied for Industry 4.0 transformation. Now, the industry is in the fourth wave of revolution. And what this means is that it's all about data exchange, data insights. It's about autonomous systems, IoT, machine learning, as well as analytics, and how all of this can be used to really advance manufacturing technologies and various processes from the edge to the cloud. And all of this is to enable the generation of insights from massive amounts of data. And these insights can then be used to make actionable decisions or take actionable decisions that can then deliver business value to the various enterprises as well as industries. And so all of this together, this fourth industrial revolution or Industry 4.0, what it's doing is really bringing the digital and physical technologies together, and it's really making all of our industries and factories more flexible, more responsive, as well as more interconnected with each other so that they can make better decisions and make faster decisions as well. In fact, McKinsey estimates that the economic impact of factory IoT applications will be about $1.2 trillion by 2025. Now you may ask, what is it about these data insights that's really transforming the industrial segment? So the factories or the world in general is generating about 1 petabyte of data per day. Now, all of this data can be analyzed in multiple ways. It can be analyzed for operational analytics, in which case we're using what is called descriptive or diagnostic analytics. And this really helps us understand what happened and why. There's also predictive, prescriptive, as well as cognitive analytics. And this really helps us predict and plan for the future. And I'll talk a little bit more about the types of use cases for Industry 4.0 that use all of these analytics or these forms of analytics to gain deeper insight into data such that better decisions and actions can be taken in a more timely and responsive and fast manner. Now, what are some of the industry and customer challenges, right? Every industrial customer we talk to is really asking questions like, hey, how can I raise my product quality? How can I better predict and reduce downtime? And how can I optimize the entire factory operation for higher throughput? If we have to enable our manufacturing enterprises as well as factories to be able to improve product quality, to predict and reduce downtime, as well as to optimize factory operations, we really need to provide an open and flexible middleware stack upon which our industry, our community, as well as our developers can innovate. Right now, the existing solutions have a number of gaps because they are either proprietary or purpose built and very highly unflexible as well as have a high cost. So, in order to address these pain points, we really need to provide our industry and our ecosystem with a very open and flexible middleware stack upon which our ecosystem as well as our developers can innovate upon. Now, let me switch gears a little bit to talk about how is Intel approaching the edge? We've talked to a number of end customers, and when we talk about how we can support them to deliver better business outcomes at the edge, it really comes down to three things that we as Intel can provide. Number one, of course, is a very diverse product portfolio. A product portfolio that ranges from beyond processors to core to atom, as well as various types of accelerators to optimize workloads such as analytics, media, graphics, as well as some of our FPGA technologies, as well as some of our custom ASIC technologies. Now, in order to support our customers and ecosystem consume this diverse product portfolio, Intel has also been investing in a number of open source developer toolkits. And these open source developer toolkits help our developer community as well as our ecosystem community to optimize workloads such as analytics, media, and networking, as well as some vertical specific offerings such as the Edge Insights for industrial. And I'll talk a little bit more about these open source toolkits because that would be very relevant to how we can further collaborate within the ONF community. And last but not least, we really work with not only the open source communities, but also with our vast ecosystem in order to be able to scale the use of these various technologies into faster deployments and faster time to market. We have a number of initiatives such as our ecosystem programs, our market-ready solutions, RFP-ready kits, as well as select solutions to help accelerate the ecosystem to go faster to deployments. Now, let me touch deeper on some of these key open source toolkits that could be useful even within the ONF community. The first is called, Openvino, which is a toolkit for deep learning acceleration. We have Open Network Edge Services software, which is a toolkit to help accelerate multi-access edge computing and 5G computing at the edge. And then the last one is the Intel Edge Insights software for industrial. Now, all of these toolkits also enable edge and cloud orchestration. They support multi-cloud capabilities. They're all open source, so we do collaborate in the open source communities for these toolkits. And lastly, they enable our ecosystem and our developer communities to have hardware scalability as well as have choice of developer toolkits from the ecosystem. And we also have something called the Edge Software Hub, which provides packages of these various toolkits in order to address certain very specific use cases. Now, let me go a little bit deeper into Openvino, OpenNAS, as well as the Edge Insights for industrial. Openvino, as I mentioned, is a toolkit to accelerate deep learning analytics at the edge. When we look at all the various use cases for the edge, almost every one of them requires visual or video analytics. And in order to be able to do this deep learning inferencing or deep learning visual inferencing, we can use Openvino. There is a higher performance around deep learning inferencing as shown by the chart below on this slide. every time our developers or our ecosystem are using Openvino. Their development is also highly streamlined, and we've been working on ensuring that we follow the adage of write once and deploy anywhere. Now let me talk about Open Network Edge Services software, which is about optimizing as well as democratizing networking, multi-access edge computing, and 5G at the edge. This is an open source software toolkit. It's highly modular. It leverages the microservices, the cloud native microservices architecture, and our ecosystem and our customers can either consume it as a whole or as in parts. And as I mentioned, it's modular as in it's composed of various building blocks that provide various capabilities from multi-access networking to resource management to data plane acceleration to telemetry and monitoring, as well as capabilities such as Green Edge. And all of this again is built on a cloud native foundation. And in fact, OpenNAS is also a certified Kubernetes distribution on CNCF. In addition to Openvino and OpenNAS, Intel also has another software toolkit, which we call the Edge Insights for Industrial. And this is also open source and modular. It's microservices architecture based. It's used for analyzing data, which means it helps to ingest the data, process it, store it, and it also helps with application and device lifecycle management. And all of this can be used by running various AI or analytics algorithms that have been developed by Intel or third parties. So Edge Insights for Industrial, it really aggregates and processes, time series as well as image, video, and audio data at the edge to enable or provide very useful insights by performing edge data analytics on this data. So now I talked about some of the technologies or the toolkits that Intel is providing. What we're also seeing is that it's not enough to just provide one type of workload or one type of technology. Almost every edge use case seems to converge or combine multiple workloads. So it's not only networking, but it's also analytics, and many times it's very specific industrial workloads, and sometimes it can also include media workloads. So the concept of converging all of these workloads, 5G, AI, media, as well as industrial workloads, all of this is becoming critical for a variety of use cases at the edge. In fact, one of the analyst reports said by combining 5G and AI, you're really looking at a 17.9 trillion impact to our global GDP, positive impact to our global GDP from both direct as well as indirect productivity value by 2035. This is a tremendous boost to our economy by combining AI and 5G together. Now let me show you what that combination of AI as well as 5G at the edge looks like. Now this slide, it talks about how can our ecosystem reduce total cost of ownership, but increase or accelerate the time to business outcomes by taking advantage of our converged capabilities, converged hardware and software capabilities. Almost all of the software here is leveraging open source toolkits, as well as some of the base underlying capabilities such as Kubernetes, Docker, or CentOS. All of this on various Intel hardware from our portfolio. It's combining toolkits such as Openvino, OpenNAS, as well as the Edge Insights for Industrial in order to address various edge use cases for Industry 4.0. Now let me talk to you a little bit more in detail about what are those use cases for Industry 4.0. When we look at what our industrial customers want to use all this hardware and software technology for, it's really around predictive analytics so that they can predict product quality or they can do predictive maintenance on their equipment. It's about defect detection so that they can really reduce production costs, but then they can increase the quality of their products by detecting defects much faster and in a more predictive manner. By identifying opportunities to increase manufacturing productivity, so what they can do is monitor production and identify various constraints and therefore improve factory production as well as efficiency, as well as automating various processes, like how can they do asset monitoring and control, or integrating multiple vendor solutions for interoperability that in turn helps to increase process efficiency or optimize process efficiency. So these are all the various types of industrial use cases that take advantage of the underlying hardware and software technologies that we are putting together at the edge in the form of a platform to deliver business value to these various industries and factories. Now let me give you a real world example. The real world example here is Audi. And what Audi did as part of its digital transformation by using predictive analytics. So now Audi, what they did is they used Intel-based edge analytics and machine learning to automate and enhance all of their quality control processes in their factories to increase efficiency and reduce costs. For example, at one of Audi's sites, they were assembling 1,000 vehicles a day, and each vehicle had about 5,000 welds, which led to about 5 million welds that needed to be inspected each day. Now, this predictive quality control solution, it really helped improve the quality control processes for these welds on these vehicles. And it really eliminated the need to perform manual inspections, which were costly, labor intensive, and also had a number of defects or unanswered questions about the quality of the car as they couldn't really inspect everything completely. So therefore, Audi, by using edge analytics and machine learning, they cut their labor costs by about 30 to 50%, but they boosted the weld inspections almost 100x with a very repeatable common platform. And this platform blueprint is serving as a blueprint for future solutions as well at Audi and potentially at other ecosystem partners and customers as well. Now let me bring it back with what does this all mean within the context of ONF? How can we from Intel collaborate stronger with ONF? And as Timon said in the beginning, we have a long history of collaborating with ONF. And we've been a strong contributor to the ONF open source community and have been involved in a variety of different projects. Some of the examples are, for example, the OMEC project, which is the Open Mobile Evolved Core, where Intel, along with various operators and system integrators, we were able to open source a 4G LTE mobile core that is being deployed in one of DT T-Mobile's Poland operational networks. OMEC is also leveraging some of the DPDK-based data plane optimizations, as well as the Intel Secure Guard, the SGX extensions, in order to protect various components of the mobile core. Ether is another project we are very involved in, which is the 5G Edge Cloud as a Service for private enterprise 5G network across distributed or scalable edge locations that can be controlled by a single or central control plane. What we are trying to do within Ether is really collaborate within the ONF community in order to help advance 5G edge cloud innovation on high volume servers. In fact, by continuing to use proven principles of disaggregated hardware, software, open source, AI, and machine learning with the Ether platform, we are really looking to drive, 5G edge cloud as a service type of innovation. We also had an announcement recently on the DARPA project. So this Ether Edge as a Service network is being operated by ONF, but as part of a $30 million DARPA Pronto research project. In fact, this is DARPA's largest funding in networking since the funding of ARPANET. And I think Ether will be initially deployed at Stanford, Princeton, Cornell, as well as various other partners and academic, and various other academic research institutions. And we're looking forward to having it also move to the industry from these academic institutions. Another area of collaboration is the SD-RAN project around real-time RAN intelligent controller, as well as machine learning-based services for improved connection and access management. Another area where we are collaborating from Intel is also the connectivity group, which basically is based on a recent acquisition from Intel called Barefoot Network. And here they are contributing heavily into the P4 integrated network stack, or called PINs, which is basically looking at how the networks can be programmed using the P4 language, and also by using switches such as the Intel Tofino switch. So we're really looking forward to continuing to partner or collaborate closely with ONF to see how we can leverage the various projects such as Ether, the DARPA Pronto project, the PINs, as well as OMAC in continuing to advance 5G and edge cloud innovations. Now, as I mentioned earlier, Intel works very closely with a very vast ecosystem, more than 1,300 plus ecosystem partners. We've been working on end user deployments, close to 24,000 plus end user deployments across a variety of different edge solutions, delivering various types of use cases. Use cases not only for Industry 4.0, such as predictive maintenance and factory automation, but also media use cases, media analytics, cloud gaming, content delivery, and of course, a variety of different networking use cases, such as traffic flow optimization, safety and security, network orchestration, and others. So we look forward to continuing to partner very closely with the ecosystem, as well as the open source communities such as ONF, to continue to advance edge solutions, as well as Industry 4.0 solutions. All of this to ensure that our industry is able to embrace, all these various technologies to deliver agility as well as lower total cost of ownership. And as we look at our portfolio of hardware and software offerings from Intel, we want to continue to support, cloud native technologies, as well as the open source community and standards. And we really want to partner with the open source community to deliver, or build the next generation of factories, as well as the next generation of edge platforms. And together with our ecosystem and our open source community collaboration, we are also looking forward to continuing to innovate to make Industry 4.0 a reality. Thank you.
So Renu, thank you. That was really terrific. I really appreciate you sharing what's going on the Intel front. It's interesting for me too, because I and ONF has been really involved with Intel for quite some time, but more on the connectivity side of the house. And you clearly have a focus on the edge side. And these spaces are converging and intersecting. And I'm really looking forward to collaborating more on your side of the house as well.
Absolutely.
It really seems like Intel's taking this notion of Industry 4.0 and this notion of convergence, as you mentioned a few times, pretty seriously, or as a real strategic imperative.
Mhm.
which I think really lines up nicely with what we're seeing in the industry and with all the other ONF partners and everything. So that's really great. I'm curious. You mentioned connectivity analytics, things like AI. You mentioned video media. You didn't mention much about public cloud, and I'm
Mhm.
curious. I mean, I suspect it's in the mix, but this notion we're also seeing in that convergence is this combination of edge cloud and public cloud, and for machine learning jobs to do inference at the edge, learning in the core. Is that are you doing work there, and is that part of kind of the mix that you're trying to pull together as well?
Yeah, absolutely. And I think one of the terms that I like to use often is edge to cloud. So everything from on-premise edge to the telco edge to the public cloud. And it also includes things like hybrid cloud, our private enterprises, all of that. So we have to take into account not only numerous types of ecosystem partners and customers, but numerous edge locations and numerous forms of deployment, because it'll likely include a combination of some of the deployments may be completely on premise with a private, kind of a private enterprise type of deployment. Some could be hybrid, they could include a public cloud component. And some of it could also be completely in the public cloud. So you really have to account for all of these different forms of deployment.
Hmm. Okay, good. Makes a lot of sense. So that it was an Audi use case, I think, that you mentioned. I'm curious,
Mhm.
if Intel and or your group was directly involved, and which of your tools might have been used in some of the case study data
Sure.
that you shared with us.
Sure. So first of all, let me explain a little bit about, our groups, right? So I'm actually part of the network platforms group that works very closely with our telco or communication service providers. So we are often on a day-to-day basis heads down in networking, connectivity, wireless technologies, 4G, 5G, multi-access edge computing. That's really what we are heads down on. But we partner very closely with our IoT group that is really looking at various industry verticals, industrial being one of them, retail, smart city, healthcare. Those are all the different verticals that our IoT group is looking at. And at the edge, we collaborate very closely with the IoT group. Now, the industrial division or industrial team in the IoT group, not only do they have strong relationships with the OEMs, ODMs, system integrators, and ISVs that we as Intel have traditionally had relationships with, but they also work very closely with the end customer. In which case, this is like a Audi or a BMW or a Daimler or others. So they work very closely with end customers as well in order to help understand, hey, what are their use cases? How can our technologies deliver better business value or better business outcomes for these end customers or end users? The same with our retail division. They work very closely with our end retail customers, like I'm just giving, anybody from a Walmart to a Target to a Nordstrom, they work very closely with these end customers to understand, hey, how can we deliver better business value, better business outcomes to them?
Hmm. Okay, good, very good. And I'm curious if Intel has a view on 5G's impact in this space, on this intersection of all these technologies. Um, why 5G is important versus, say, Wi-Fi or other connectivity mechanisms, or what your view is on ultimately what percentage of connectivity might be via private cellular and 5G in the next, I don't know, 5-year time horizon. Any insight there?
Absolutely. Sure, absolutely. So I think from a 5G perspective, right, the 5G brings in certain key capabilities such as ultra reliable low latency, the enhanced mobile bandwidth, machine to machine communication, network slicing to be able to deliver, quality of service differentiated capabilities or quality of service guarantees in individual network slices, as well as much better or higher security and reliability. All of these technologies make 5G very, very attractive for Industry 4.0. Now, that said, I do believe that it will have to coexist with Wi-Fi. I do believe that there will need to be seamless or frictionless connectivity across, Wi-Fi, wired as well as wireless. I think that's really why we call it multi-access edge computing, because I do believe that these technologies will need to coexist. And even our end customers will really look at, hey, if there are some things that they don't want to either change, if there's something on Wi-Fi that they don't want to change, they will continue to keep it on Wi-Fi. But if they can deliver better business outcome, better security, better reliability, better quality of service, and much lower latency for faster response time in some of the use cases, they will definitely use 5G there. And at least I think that's how we really see all these technologies will coexist.
Mm-hmm. Yeah, okay, good. Well, thank you very much. Well, Renu, this has really been great today. Thank you so much. I'm so glad you've been able to join us, and I'm really looking forward to collaborating more with Intel in this edge space.
Absolutely.
So thank you.
Absolutely.
Thank you again.
Yeah, my pleasure and my privilege. Thank you so much.